So, hello everybody. Today I explain last project of OpenCV University course about deep learning application and development application. The last project is about face detection, and we can show the task is detect the face mask on the samples and image samples and on the some sample of videos. So if we check it, we will create two models, and these models are YOLO's models. The task is YOLO version 3 and YOLO version 4, but this is the which we have in course. This YOLO version 3 and YOLO version 4 is created by DeepNet, by Darknet, Darknet, and it's C technology, and I tried, but I have problem with Kaggle with some libraries. First thing, and second thing, I have problem with learning with setting some inputs. But I don't know. But from my side, this is the very fast technology, and OpenCV library have some possibilities of use it, but this version of YOLO are very old, and I think it's for creation real application is not good. Stay on old technologies because for future it's difficult for updation and shifting your projects. Usually a better way use last version and last technologies, and if you want to use this for specific for this project, from my side it's possible use only as technology with container and frozen container, because for future we have problem with the C libraries of operation system when these projects too will be run for future. So I try check the new versions, because from where YOLO version 5 is YOLO created by new technology. It's jumped to the PyTorch technology, and these models I create by PyTorch. So we in our project I test version 5, 6, 7, 8, 9, 10, and I check some possibilities, how train the models, how use the models, and I show which possibilities today are, and where is some problems, and where is some solutions, and which are benefits of the solution, which are little bit dangerous of these solutions. Okay, so first I everything is take in my GitHub. If you go my GitHub and show the repositories, I have OpenCV project 4 repositories. There's the documentation about my project. So what we do? We must train the model. Um, from OpenCV, we have a training dataset and testing dataset. So I show where I have this dataset, train dataset. I give to the Kaggle. Then, if you show in Kaggle, there's this dataset. I usually import both datasets into the Kaggle, and for my work, I linking and download these datasets by using in Kaggle notebook or by using Colab. The last things as testing in testing samples and videos, I use normally local Jupyter Lab notebook. So just see now the GitLab or GitHub. Sorry, GitHub. And we start with training explanation. So, okay, just a minute. I must jump maybe there. Okay, so I start with YOLO 5. Okay, I open the collab. All documentation is inside the GitHub project, or maybe some case. So for today, it's possible train the YOLO project maybe 2 or 3 ways. Others version 3, 4 are trained by darknet. The version 5 and newest is possible trained by PyTorch project, or there is the next possibilities by using library ultralities. This is the very effective way with some benefits, but with some something is because it's as black box, it's not good for viewing what happens inside. So I can show you first something about Ultralytics, because there's the good documentation. So there, if you check of the Ultralytics documentation, I must check where's the YOLO. I think just a minute. Maybe there it's faster. Everything is inside our documentation. Few very interesting things I add there. Okay. So the Ultralytics have very nice documentation about some version of YOLO, but library of Ultralytics support few versions. Um, we can use it for version 5. You can use it for version 8, 9, and 10. Version 6 and 7 it's not supported. Yeah. So this version 6 and 7 I create by GitHub project by PyTorch. Okay, so but for the version 5, 8, and 9 and 10, I use this library because it's so much faster, so much effective, and it's with I can show last next step. There is the something what I don't know how I work it, but when I tested the models and use this library from Clides, I have much better uh, better results as I use standard Onyx runtime or OpenCV library. I don't know why there is some thing what's maybe is task why it's not so effective, but I can show you later. So this is the first thing. We start with YOLO version 5. Okay. From Ultralytics, the steps are still same. You install Ultralytics and something else what is necessary. Then you download train dataset. Okay, I create a rebuild. This is one thing. The problem with some version is the, the this version 8, 9, 10, I think 5 have same structure of train data for training, but version 6 and 7 have a little bit different structure of for training. Yeah, be careful because you must create the training dataset with right structure of dictionaries and fast. Okay, so then we create a dataset. Then we rebuild dataset for our training project from YOLO 5 version. Then I add the next challenge. Usually, you need a YAML file for training, and often you download and handle rebuild, but there is the script which create automatically, and we don't do by handle, and so some problems. Where is it and how update? You only run the notebook and the script create this configuration YAML file for training. It's easy. There is the number of class, name class, where's the dataset, that's validation train, and something else. Okay, this is the handling creation of YAML file and saving from project. This steps is all times same because this YAML file is still same for all version of YOLO from 5 version to 10. Next is downloading testing dataset, and we start with we try this library with training our model. We only download the train model which is in project. Usually, if we check, okay, just a minute, I show you. We have GitHub, okay, and GitHub version. If you check, yeah, there's the some versions of trained model. So we use the middle version, which is named with M. I think I try usually some large model. This model, I don't know. There's a problem with testing because this is very large, and there's a problem with some resources for calculation. This possible use, but this is the if you use Colab, you will be maybe problem with free version of Colab because this is very large model for training. So for our project, we usually use middle version of version YOLO. So then we download the weights, which is trained and saved. Okay, we use this version. Then you train data by calling our YAML file, and then we only save our trained model. Okay, everything's run, and there's the some. That's nice because this kind projects from Utility create some metrics and some documents for viewing what's happened by training. We can show it and check it. Next things we check training data, how was used and how was trained model. Okay, we can show some additional metrics of training. Next, evolution dataset, because we automatically train that model and evaluate model. And last things, we use our test pictures image from this project. Okay, we can show that in our image which we use for testing model in project show very nice, looks like it's nice, results are okay. So then last things in Colab, we automatically download our train ways models, and I can show you because for application from great uh, application, we won't use something with it's compatible with some languages and is better for creation. Our goal project it's use conversion from Linux model. There I can show where is it, and it's very easy. and we may be showing why and what's possible. Okay, there is using Oryx model, but train export. There is the export. Okay, export is only this. We take path for export, and because we use it checking how effective this model is, so we only use model export for export warnings, and the model will be created on the same directory level as our best weight train weights of PyTorch. Okay, so we export and download both models warnings and models from PyTorch in these last steps, and this is everything what you need. Now we have trained model from version 5. So next we show you how is create the YOLO 6 version, YOLO 6 version and 7i train on Kaggle notebook because I need free resources of GPU, because for training all models it's necessary to use GPU. Okay, let's start project. So again, we now in this version we don't use the Ultralytics library because this version model is not supported by Ultralytics. By this library, we download the project from repository and use the project standard way. Okay, we clone Git repository, we create configuration file and in the steps, and the install requirement, we download the necessary libraries for this project clone. Next, we create the YOLO file. Then we download from repository pre-trained weights of models. Then we training the model by this task. Okay, so if we have a trained model, we again show some evaluation. We validate the model and we show results on our testing image. So last thing, we convert model to Linux format. So I can show you what happened. Okay, this is problem because the origin, the the project have some script for creation of Linux file, but for my side it's a little bit problem because when I use it and testing this Orange model, the result false. It's I don't know why, but I can show you later the models not run right. I don't know why, but this is the challenge from future for deep showing or learning how Onyx functionality is and where's the problem with this script. Okay, if we show the yellow version free repository, there is the script. Okay, evolution we install. I don't know. I don't know. I don't sure where is it, but I think in some projects interface you deploy. Maybe this is the script from deploying export. This kind of script we use. The second way which I testing in my samples is do myself by PyTorch, but I don't know. The results was same. The model still work false. It's still same. I don't help it myself. But I tried export myself by PyTorch. Then I have from some models 2 or 3 versions of ONX models. But I can show later the models are false or I don't know why, because the exportation will be with same results. So we have export model. Next we jump the next version. Okay, the next version is VL7. This version, okay, I open GitHub, I open Kaggle notebook. So, okay, no, it's not necessary. So we first check the official GitHub project. We again have some pre-trained weights. In this version, although we haven't the same type of mm, names of the versions, we have a middle model, we have only base model and something others model. Use this version, base version of model from train. Okay, so again, we in Kaggle we download some things, but we connect the dataset, we rebuild datasets because the structure of this is same as in version 6, and the version 6 structure I can show you is different of version 5, 8, 9 and 10. Yeah, just a minute. So because there is the showing how must be create the training data set. Yeah, there's the differences because there's the different level of annotation and images for training. Yeah, the next mm, version are the different levels of this directories. Okay, so version 6 and 7 is similar, but 5, 8, 9, 10 versions are different. So we built our train dataset with the right structure. We create a YAML file for training. We install a repository. We check there is some in your 7 some problem with the version some libraries they have some additional technical fix problem, but still with training will be next steps again set specific version from NumPy library because if you don't do it you can train the model. So I use the last version from first time I install last version by from additional things as build the dataset and something else, and from train I must reinstall the numpy. Yeah, this steps is necessary because I have incompatibility NumPy library from training, and I in this position I must uh, reinstall and install right version of NumPy. Then we train model and evaluate model, and we check it our images, results. We show results still is fine. uh, there is something what is very good from 7. I will talk about this later, but maybe if we show now I can explain. There is the in the 7 version is possible detect video file. We have the same similar way how detect object on the image, and there's the how detect on the video. I don't know, is it in version 6? I try check it, is it some script there, but I think it's now it's not possible. Do inside project must create by handle. Yeah, okay, but in version 7 it's this possibilities. In version in 4 and 3 in darknet in there's in project same possibilities create the detection of the video maybe, but I don't test it. So we evaluate the video, our videos, then we export the module. So in this version, I try export model in 3 types possibilities. I try use standard script from the project. I think it's this scripts. Okay. I try use the handle exporting by PyTorch, and I try a little bit. It's on hard way use the test if possible use the ultratext library only for exporting to the ONX format. In this case, this export run, but Ultralytics don't totally support with this without some problems. There was some warning, and the export is not right. Still, okay. There's the show how I export it, because for this I have a free version. Just a minute, I must. Yeah, there's the handle export. Yeah, this is the by PyTorch, and this is the export by Ultralytics library. This is export from using a script of project, but results are same. The models are not right. I don't know why. I show later where's the problem. So uh, now we have version 7. Next we jump to version 8. Okay, I can open. This version is possible built very fast by Ultralytics. It's nice functionality. So we open the notebook. Just a minute. So still the same way, we download and create dataset with the right format. We create a YAML file. We download testing file. We use the middle version of weights of training models. Then train it again. We same way show some metrics and something else. We show the testing images. Why train? We show some additional metrics and validation data set. And last, we try use our image for testing, and there's the maybe one show one test 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 images, because we have dataset create from train model, evaluate and test. And next we have additional testing images from project. So this is from test some set from test part of train data set, and this is the project testing samples. So next we train the unit 8. Open this and this. Okay. So again, this is possible trained by Ultralytics library or by project. We use Ultralytics because it's more simplified and faster. So we use again middle version of model, and if we show it's still same, it's again create configuration file, same steps for training, same step from checking and evaluation. Okay, it's still similar. Yeah, results are fine. We download best PT model and best ONX model. Okay, there's the ONX export by Ultralytics library. So next we jump to the last version of YOLO. The last version of YOLO is version 10. Okay, I open again. It's possible by using the UltraX library and exporting steps are same still. Okay, results are show same way. Okay, we export. So one thing in this version, if I use the Ultralytics for exporting the ONX model, these ONX models are wrong too. I don't know why this export are right functionality, because if I use Sembay from modules 9 and 8 and 5, ONX models are okay, but for export 10 version models there's some problems. I don't know which problem, but the model art's not usually used normally way as others. So next things what I show it's this all models I save on Kaggle for checking and from downloading. Then I can show you in Kaggle I have some model that models save and it's possible to download. Okay, so I can show you some information about models. I don't know, maybe there's better, just a minute. And GitHub it's not showing good, but show description I show in this normally because I use the local notebooks, and I can show some tables with these models. Okay, I use the for again, but I don't show this version how create, but it's similar with I use in version C and 6. I try export by handle by PyTorch way model warnings and for testing and save it. This is the version exporting by Ultralytics library. This is by PyTorch script, and we can show some metrics of ONX models. We show that is ONX models. We check uh, which is higher and which is lower with kilobytes. We check a number of inputs. This is for all models same, but this is very interesting. We have same inputs from models. This is okay. This is same tensor, but there's the differences difference is the names of inputs. Okay, if we use Ultralytics library, the inputs its names images. If you use some PyTorch and we do not specify standard inputs, its no input. And second thing, output names for Ultralytics library is name usually output 0 for it's for I can show it's for a detection model because YOLO version 8 and 7 have some different models, not only for detection but for other types of analysis. I can show for later. Okay, and now we have three names outputs, and we must work with this if we create the Onyx script for all. Yeah, we have output 0, we have output, and from 6 version is output. Yeah, and next things we will check what is different, what is very interesting, the shape of outputs. Yeah, because standard is when we use Ultralytics library and check model 9, 8, and model 5, the output is this shape, and we must create some transformation. But for version 10, 7, and 6 is different outputs, and in this case, we don't use it the additional transformation of outputs for working. So this is the interesting task that we must check and a little bit work with this in our script. Okay, so next things interesting with me check if I use the in this case Ultralytics library for export, I have only one output. If I use Python script, I take 7 outputs. Interesting, and this is the same thing if I use the script from GitHub repository. I have 4 outputs. If I use the wrong Ultralytics library, because Ultralytics is not compatibility, you can show I have 3 outputs and there's the wrong type of model. Because the Ultralytics is not compatible with this version of models. Yeah, if you use it, the results of expert are very worse. Then I use the Python script for export, and I have some same results as standard script on the GitHub repository. Okay, for output. So next, last, there is the showing PT file only from view, and this is maybe all with this. So I think now it's time to take break and create next video, because in next video we will check the results and show how we use Onyx model with 3 ways. for working with detection on images and 2 ways on detection with videos. Okay, in this video it's all. Thank you for watching. I think in next part is very interesting too, because we show how work with OX file. Okay, so see you later and bye.